Hi everyone! In the previous video, we have introduced IPv4 over IPv6. This is a tunneling technology used in the later stages of IPv4 to IPv6 transition and can interconnect IPv4 islands. Today, let's focus on another tunneling technology, IPv6 over IPv4. This technology is used in the early stage of IPv4 to IPv6 transition. In the early stage of the transition, the backbone networks are still IPv4 networks, and the carriers wish to establish communication between local IPv6 networks. IPv6 over IPv4 offers fast tunnel deployment. By doing so, isolated IPv6 networks can communicate with each other through tunnels. In an IPv6 over IPv4 tunnel, IPv4 headers are added to IPv6 packets, converting these packets into IPv4 packets. They can then traverse the IPv4 network through the tunnel, enabling IPv6 islands to communicate with each other. The packet forwarding process is similar to that in an IPv4 over IPv6 tunnel and is not described here. Based on application scenarios, IPv6 over IPv4 tunnels are classified into IPv6 over IPv4 manual tunnels, 624 tunnels, or 6RD tunnels. An IPv6 over IPv4 manual tunnel is manually configured between the two border routers. The source and destination IPv4 addresses of the tunnel need to be statically specified. The source address of the local tunnel interface is the destination address of the peer tunnel interface. A virtual IPv6 link is established between node B and C. When there is a reachable route between the two nodes, IPv6 packets can be transmitted. Differing from a manual tunnel, a 624 tunnel is not configured in pairs. A 624 tunnel uses a special IPv6 address, which consists of a fixed IPv6 address prefix, an IPv4 address, a subnet ID, and an interface ID. The IPv4 address is a globally unique one applied by an IPv6 island. The subnet ID and interface ID are allocated by users in IPv6 island. A 624 tunnel can implement interworking between 624 networks. On 624 networks, the IPv6 addresses of all devices are 624 addresses. When creating a 624 tunnel, you only need to determine the source address of the tunnel. This address is also the address of the physical interface through which the border router connects to the IPv4 network. The source address of the tunnel also determines the IPv6 address of the tunnel interface. The destination address of the tunnel is obtained from the destination address of the original IPv6 packet. After node A sends the original IPv6 packet to node B obtains the IPv4 address from the destination address of the packet and encapsulates the IPv4 address into the destination address field of the IPv4 packet header. In this way, a 624 tunnel can be established to transmit encapsulated IPv4 packets. A 624 tunnel can be used only for communication between 624 networks. However, with the development of IPv6 networks, common IPv6 networks need to communicate with 624 networks through IPv4 networks. This can be implemented through 624 relay. The method of creating a tunnel between a 624 relay router and a common 624 router is similar to that of creating a tunnel between common 624 routers. However, a static route needs to be specified from the common 624 router to the IPv6 network. The 624 tunnel can forward an IPv6 packet whose next hop address instead of the destination address is a 624 address. After obtaining the IPv4 address in the next hop address, node B encapsulates the address into the destination address field of the IPv4 packet and forwards the packet to relay router C. Thereafter, relay router C forwards the packet to the IPv6 network. In this way, the 624 network can communicate with the IPv6 network. Finally, let's look at the 6RD tunnel. 6RD tunneling technology is an improvement on the original 624 solution. A 6RD address consists of a 6RD prefix, an IPv4 address, a subnet ID, and an interface ID. Different from 624 addresses that use a fixed IPv6 address prefix, 6RD prefixes can be allocated by carriers from their own IPv6 address space. Therefore, different carriers can use different prefixes to deploy 6RD tunnels. The 6RD prefix and part or all of the IPv4 address from the 6RD delegated prefix. The IPv6 addresses of all devices in the 6RD domain must contain the 6RD delegated prefix. In this context, 6RD domains can communicate with each other through 6RD tunnels. Specifically, the carrier specified the tunnel source address, IPv4 prefix length, and 6RD prefix on 6RD CEB. After calculating the 6RD delegated prefix, the device delivers it to node A. With the 6RD delegated prefix, you can configure a 6RD tunnel and address of the interface connecting 6RD CEB to the 6RD domain. To implement interworking between 6RD domains, you need to perform the preceding configurations on the border routers of the IPv4 network and the 6RD domains. The packet forwarding process in 6RD tunnels is similar to that in 624 tunnels. After receiving an IPv6 packet from node A, 6RD CEB calculates the destination address of the tunnel based on part of the IPv4 address in the destination address of the packet and the source address of the tunnel. It then forwards the IPv6 packet. Similar to a 624 relay, 6RD relay can be used to implement interworking between a common IPv6 network and a 6RD domain. All packets destined for the IPv6 network are forwarded to the 6RD BR router, which then forwards the packet to the IPv6 network. Next up, we'll compare the three types of tunnels. According to the method of obtaining the IPv4 address of the tunnel egress, tunnels are classified into manual tunnels or automatic tunnels. The 624 tunnels and the 6RD tunnels are automatic tunnels. IPv4 addresses of the ingress and egress need to be manually configured for an IPv6 over IPv4 manual tunnel. In contrast, only the IPv4 addresses of the ingress need to be manually configured for a 624 or 6RD tunnel. The border devices can automatically obtain the IPv4 address of the egress of the 624 or 6RD tunnel based on the destination address of the packet. In this context, IPv6 over IPv4 manual tunnels can be used to implement only point-to-point connections, while 624 and 6RD tunnels can be used to implement point-to-multipoint connections. The three types of tunnels have their own pros and cons. Manual tunnels are easy to configure but difficult to deploy on a large scale. In contrast, automatic tunnels are more complex to configure but easier to deploy on a large scale. Beyond that, the IPv6 address prefixes of 6RD tunnels can be configured by carriers. In this case, 6RD tunnels are more flexible in network planning than 624 tunnels. This is why the 6RD tunnel is the most commonly used IPv6 over IPv4 tunneling technology. As we are drawing to a close, let's summarize what we've discussed so far. As a transition technology, IPv6 over IPv4 makes full use of the existing networking. The dual stack function needs to be enabled only on the border devices of the IPv4 and IPv6 networks. The internal devices of the backbone network do not need to be upgraded. This technology is easy to deploy and can quickly interconnect IPv6 islands without high requirements on the backbone network. However, IPv4 and IPv6 hosts cannot communicate with each other directly through IPv6 over IPv4 tunnels. In addition, tunnel data needs to be maintained, which increases network overheads. Packet encapsulation and decapsulation increase device processing delay, potentially degrading network quality. With the popularization of IPv6 networks, carrier networks will directly communicate with each other by fully supporting IPv6. At that time, IPv6-only networks do not need the IPv6 over IPv4 tunneling technology. Through the support of IPv6 over IPv4, we expect the transition to IPv6-only networks to be a quick process. That's all for this video. Thank you for watching. See you next time.